Go big or go home, right? That's kind of how I feel. So before we can start to solve and review the three variable system, we have a little bit of preliminary work to do on these equations so that we can get them to look like what we're used to. Tori, bring it. Leave it right there. So, in your opinion, any gut feelings as to what you could do with this to get it to look like the types of equations we're used to? Joseph?
You could get them all to have a common denominator, and then just, since they all have a common denominator, just like get rid of it.
Right, get a common denominator and drop it, right? Because then that equation would be the same as just the equation formed out of the numerator. So what would that common denominator be here? 4. So this one gets multiplied by 2 over 2. This one gets multiplied by 2 over 2. This one gets multiplied by nothing. This one gets multiplied by 2 over 2. So in our numerator we distribute, you get 2x plus 6. In the second term, you are distributing a negative 2. So be careful of that, because the minus sign can throw you. And when you distribute that negative 2, it's going to become negative 2y plus 2. And then plus a z plus 2 equals a 6. By getting a 4 all the way across, then technically the step that you don't see, because it's kind of pointless to show every single time, is that you're multiplying both sides by 4. So it gets rid of the denominator of 4 on both sides. So we just kind of say, oh, I'll cross it out. But that's technically what's happening. When I clean this up, it's going to be 2x minus 2y plus z equals, and we have to figure that out because we will subtract this 6 over. We will subtract the 2 over. And we will subtract another 2 over. So it'll end up equaling negative 4. And there's equation 1. Yep. Because this is the preliminary work before we can even start the system stuff that we already know how to do. So in the second one, I'll essentially do the same thing using a little bit of a different technique. I'll use the clearing fractions technique. So if you have 2, 3, 4, and 6, what's the least common denominator of those? 12. So I will kind of right away multiply both sides by 12. Now, on the first term when I distribute, the 12 and the 2 will cancel to become a 6. So it'll be 6 times this x minus 5, which is 6x minus 30. On the second distribution, the 12 divided by the 3 reduces to a 4, so I'm distributing a 4 to the y plus 1, which is 4y plus 4. And then on the third term, the 12 and the 4 would reduce to 3, so I just am getting minus 3z equals, and on the right-hand side, the 12 and the 6 reduce to a 2 times negative 25 is negative 50. When I clean that up, I have 6 x's, 4 y's, minus 3z equals, I'll have to add the 30 over, subtract the 4 over, and that leaves me with negative 24. So, which one do you like better? Raise your hand if you like the first way better. Raise your hand if you like the second way better. Okay. You can do what you want. I don't, honestly, it doesn't seem like there's an overwhelming majority one way or the other. They are just doing the same thing, right? If you were getting a common denominator here, you'd get it to be 12, you'd have to multiply by 6. That's what we did. You'd have to multiply by 4. That's what we did. You'd have to multiply by 3. That's what we did. So it really is the same thing, just kind of a different way of looking at it.
Can you go over that simple math?
Go.
Negative 50 plus 30.
Negative 50 plus 30 is negative 20.
Yeah.
And then negative 20 minus 4 is negative 24. So on the last one, 4, 2, 2, and 2, I would just get all my denominators. I'll do it that way to 4. So the x minus 3 is going to stay the same. This one needs to be multiplied by 2, so I'm distributing a negative 2. That'll make it negative 2y minus 2. This one's getting a 2 over a 2. So that'll be plus 2z minus 6 equals, and this one's getting a 2 over 2, so that's equaling negative 10. When I clean that up, I get x minus 2y plus 2z equals, I have to add over a 3, add over a 2, and add over a 6. So that's negative 10 plus 11 at the end of the day, which is just 1. So now here's the type of system that I'm used to from Algebra 2. Now the way you guys, I believe Mrs. Zig, I taught you substitution and elimination methods. I feel strongly, and maybe it's just personal preference, that elimination is more efficient, cleaner, more often, doesn't get messy like some substitution ones get. So I will always do elimination. And I kind of phrase it to my Algebra 2 kids is that you solve these using elimination 3 times. The first 2 times you eliminate the same variable twice. And then the third time you eliminate another variable. So I'll kind of teach it using the phrases that I use. And you, at the end of the day, you can do it whatever way you want to. I'm assuming you guys are pretty good at these, but we shall see. So when it comes time to deciding which variable, you have to get your coefficients to be the same. So you have a 2, 6, and a 1 on your x's. You have a 2, 4, and a 2 on your y's. And you have a 1, 3, and a 2 on your z's. I don't know, Lexi, which one do you think would be the easiest to get all the same variable in front of?
The first one, the third one.
Well, what variables?
Oh, the y's.
The y's. So I'll just start by making all my y's the same coefficient of 4. So this first equation's got to get multiplied by a 2. That's going to make it 4x minus 4y plus 2z equals negative 8. My second equation gets nothing. It already is a 4. And my third equation gets a 2 as well. So then I just do one round of elimination with the first 2 equations, and then a second round of elimination I'll do with the second 2 equations. If you really want to do a round of elimination with the first and third for some burning reason, you can do any combo of 2 that you want. I just keep it simple. So the first 2, if I want the y's to eliminate, am I going to add or subtract these equations? Add them. I have a motto that's opposite signs add, same sign subtract. Okay? So this is a negative 4y, this is a positive 4y, those are opposite signs. So you add, and that will cause them to eliminate. So if I add these, is that a negative 4? No, it's positive. 4 plus 6 is 10x. Your y's cancel. 2z plus negative 3z is negative z. Equals negative 8 plus negative 24 is negative 32. There's round 1 of eliminating the y's. Round 2 of eliminating the y's, I'll use the second 2 equations. Add or subtract? Add again. So I get 8x. Negative 3z plus 4z is plus z. And negative 8 plus 2, negative 6. There's the second round of eliminating the y's, which leaves me now with a traditional system. Now you get to choose again which variable you want to eliminate, the x's or z's. Here it's glaringly obvious that it's easier to eliminate the z's because you don't have any need for multipliers. Yes? Add or subtract. Opposite signs add again. So I get 18x equals negative. Did we do something wrong?
Yeah.
Where was it?
It's negative, not positive, I think.
Where did you get -6 from?
Yeah.
I have no
It's
idea.
not negative 6.
It should have been
Go back
negative
at-
24 plus 2, so it should be negative 22. So negative 32 plus negative 22 is negative 54. I like that better. Divide both sides by 18. X equals negative 3. And then it's just a domino effect backwards. So if I know X, I can go back here and find Z. So 8 times negative 3 plus Z equals negative 22. I'll have to add this 24 over. And I get Z equals 2. You good, Nick?
Yeah, I'm good.
And then you know those two, so domino effect back to, I'll just go to this equation, although if you want to use a different one, you can. So I'll have to add this 6 over. I'll also have to subtract this 8 over. And I'll have negative 4y equals 0. So y equals 0. You guys obviously know that with a traditional two-variable system, the solution is a point in the xy coordinate plane, right? There is a three-dimensional graphing system out there with x coordinates, y coordinates, and z coordinates, which give your image depth. So it's not uncommon to see your answer written as an x coordinate, y coordinate, and z coordinate combo. It's nothing you'll learn about in high school, but it exists, and so for that reason, you kind of also write this solution as a point. Good? Any questions? Okay. So one of the uses of this, writing the equation of a quadratic function. Okay? You've written equations of quadratic functions with focuses and directrix. It's a totally different ball game than what we're dealing with here, but you've done it with if you specifically know the focus and directrix or the focus and the vertex or any combo of those three. You've also written quadratics just knowing the vertex and a secondary point. That's enough information. This is going to show us how we can write the equation of a quadratic given any 3 points. None of them have to be specifically the vertex or a focus or directrix. And it's going to use a system of 3 equations. So anytime you have points, you plug them in. So I'm going to plug in 1, 4, which is going to give me 4 equals a times 1 squared plus b times 1 plus c, which will clean up to 4 equals a plus b plus c. When I plug in the second point, I get 1 equals a times 2 squared plus b times 2 plus c. And that cleans up to 1 equals 4a plus 2b plus c. And when I plug in 3, 4, I get 4 equals 9a plus 3b plus c. So which variable most obviously should be solved or eliminated, I guess I should say, first? The first 2 times. C, correct. So add or subtract? Subtract. 4 minus 1 is 3. A minus 4a is negative 3a. B minus 2b is minus b. And c minus c is gone. In equations 2 and 3 now, also subtract. Same sign on the C's, so subtract. 1 minus 4 is negative 3. 4a minus 9a. 2b minus 3b. Now for my third round of elimination, which variable is most obvious to eliminate? B. Add or subtract? Subtract. Same sign on the B's. Subtract. So 3, you got to be careful here because you're going to have a lot of double negatives. 3 minus negative 3 is 6. Negative 3a minus negative 5a is negative 3a plus 5a, which is 2a. And negative b minus negative b is gone. So a equals 3. Go backwards. Add 15 to both sides.
I didn't know like what equation like the A is.
It doesn't matter. It would have to be either one of these two. I'm just doing the bottom one every time just so it's a little more clear. But I couldn't plug it back into one of the originals because if I'm only plugging in A and I still have 2 unknown B's and C's, that's no good. So that's why I kind of just domino effect backwards. Now I have A and B and I can go into any one of the 3 of these. The first equation would probably be the easiest, but just because I'm neurotic about organization and I like things to line up, I'm going to use the third one. So I would subtract the 27 over, add the 36 over, and I get C equals 13. So the equation of this parabola that we just wrote that contains these 3 points, y equals 3x squared minus 12x plus 13. And also because I'm a geek and I love to prove to myself that math works, I'm going to type it into the calculator. The equation we just wrote and then I'll confirm that it has each of those 3 points by using the trace feature. So if I do second trace and value, if I want to know the point when x equals 1, it's supposed to be 4. So you put in 1, hit enter, 4. Second trace, value, plug in 2, you're supposed to get 1, you get 1. And then second trace, value, plug in 3, you're supposed to get 4, you get 4. Do you guys, just on a side note, you remember when you had like a scatter plot? And you edit your lists and you insert your points 1, 2, and 3 as your x coordinates, and 4, 1, and 4 as your y coordinates. And then you turn on your scatter plot and you would graph those 3 points. And then you run a regression. So stat, calculate, and knowing it's a quadratic, if you run a quadratic regression, your x coordinates are in list 1, your y coordinates are in list 2. Calculate, A is 3, B is negative 12, C is 13. And they give you the format for the best fit equation up top. And do you remember correlation coefficients? The closer they are to 1, the stronger the correlation. This would have an exact correlation coefficient of 1 because it's not really a scatter plot. It's actually the perfect points that fall on that graph. And so because there's no variance at all, you would have a correlation coefficient of 1 because it's a perfect graph. Goes through all the points. So it wasn't really a true scatter plot, but you get the point. Okay? All right. I am. Yeah, the lockdown killed my period 2 recording opportunity. So here we are. On this next one, I just started with one that was a little bit different. Obviously, I think it's obvious because the y is missing in the first equation. So, since the y is already eliminated the first time, we don't have to do that round of elimination. We've already got a y eliminated. Then in the second two equations, let's also eliminate the y. That'll be technically our second round. So multiply by 2. Add or subtract. So I get x plus 3z equals 18. And the first equation I'm just going to straight up use, x plus z equals 8. And then which variable should I eliminate? X by adding or subtracting? Right. Z minus 3z is negative 2z. 8 minus 18 is negative 10. Z equals 5. Go back. X equals 3. Go back. So the only reason I threw that one on there is just kind of showing you how to look at a problem and use it to your advantage if you already are missing a variable. Honestly, a lot of people would say, well, all the x's already have a 1 in front of them, so I'm just going to do my elimination of x's and I don't need multipliers, whereas you needed a multiplier doing it this way. True. You could argue what's most efficient, but just, showing you a couple options. Why don't you try this one on your own? I have an idea. Stop. You guys eliminate the x's your first 2 times. You guys eliminate your y's, and you guys eliminate your z's. Yep. To start.
Okay.
Is there anyone that wants to do substitution? That loved that method?